Hi. A very common question in noise measurement is, what is LEQ and how is it measured? And is one that people often get a little confused over. So hopefully this video will help to make things a little clearer. The EQ in LEQ simply stands for equivalent. So the LEQ, or LAEQ as it is sometimes written, is the equivalent continuous sound pressure level. It is a very common and important measurement parameter designed to represent a varying sound source over time as a single number. In other words, if you're looking at a changing sound over 3 minutes, it would be very difficult to know what that means as the numbers keep, well, changing. The LEQ will tell you what the level would have been if it had been a constant sound. Some people think of this as an average sound level, which, although not strictly correct, can help to understand what it is telling you. You can see this in the short clip on screen now, where there is a varying sound source in blue and a yellow line that represents that sound as a single number, or what the sound would have been if it had been a constant level. LEQ is actually a measure of the energy contained within the sound. This is very useful in terms of the potential for sound to damage or disturb, and this is why it is extensively used in environmental noise standards, as well as noise at work and many other regulations and documents. On a modern sound meter, it is possible to take LEQ readings in durations as short as milliseconds, although that would require a fairly specialist application. Normally LEQs would be taken over a minimum of, say, 5 minutes, with many environmental applications requiring 15-minute or hourly periods. You can even have an LEQ of many days if you wanted to. LEQ can be measured with either A, C or Z, which is sometimes called linear, weighting filters. But A weighting is normally used as this represents how the human ear hears sound, and most applications for LEQ are human related. It is really important, if you need the A-weighted LEQ, to make sure the sound meter is in that mode, as you cannot convert to C or Z afterwards, unless you have measured all the octave or third octave bands. Remember that it's not an average sound level that it's sometimes referred to. You can measure a single LEQ to give you a single number, or you can take repeated measurements to create a time history, like the one you can see on screen now, which shows a 30-minute measurement broken down into 1-minute LEQs. For those of you interested in more of the technical detail about LEQ, then here's a little maths. LEQ can be described mathematically by the equation you can now see on screen, where PT is the instantaneous sound pressure of the sound signal and P0 is the reference sound pressure of 20 micropascals. For those of you with a little maths knowledge, you will see that this is the logarithmic average of the sum of the squared pressure levels with reference to 20 micropascals. You can also calculate an LEQ from discrete sound pressure levels or from shorter LEQ values. To do this, you can use the equation on screen now, where dBn are the individual sound pressure or LEQ values, and n is the number of those values used. This time you can see that this is the logarithmic average of the individual decibel values. I hope you enjoyed that little extra techie bit. And if you want to talk to one of the team about anything we've discussed here, then please don't hesitate to get in touch. All the details are on our website at www.castlegroup.co.uk. Also, don't forget to subscribe to our YouTube channel to see more videos like this one. Have fun and bye for now.